Hi, everyone. Just would like a minute of your time. My name is Austin. I'm here representing HKN, the EECS Honor Society, and I just want to say that we are hosting a final review session next week. That'll be Tuesday from 11 to 2 p.m. And it'll be in HP Auditorium. That's 306 Soda. I know this room is a bit on the small size, given how many students are in this class, but it was the best that we could do. We'd love to see you guys come out to the review session. And of course, as always, we'll have the slides and the solutions posted afterwards on Piazza. This info is not yet on Piazza, but we'll get it up there today, so you guys can reference that. I think that's it. We will do our usual drop-in tutoring over Dead Week, so feel free to drop by and get help from us as you usually do. Thank you.
Thank you.
All right, we have one more announcement today. It is John's birthday, and we're all going to sing. All right, so let's try to do this in sync. 1, 2, 3. Happy birthday to you. Happy birthday to you. Happy birthday, dear. Happy birthday to you.
That's awesome. Whoa. I love that.
We also have cupcakes, but not for everyone.
Just for John.
I got cupcakes. Thank you. Yeah. Can we do it right after, maybe?
Yeah, so we've been telling our students all week to come to class so we can sing to you.
So as you probably know, this course is only possible through an excellent staff that really does all of the teaching. So maybe take this moment to thank all the people who came up here while we do photos. Okay.
Happy birthday.
It is actually time for lecture number 38. And you came. That's so nice. If you're used to watching me on video, I will talk very slowly. Sorry. Okay. I have some announcements. We're at the last lecture of the course. Though if you've been keeping track of all the points, you'll notice that we're not done assigning homework points. There have been only 20 points of homework so far out of a total of 25 in this course. So we have to make up for that last 5 points. Homework 11 is due Wednesday. All you have to do is complete the final survey for the course. Okay, so this is actually important. The survey asks you a bunch of questions about how things went in the course. We use that feedback. We take it very seriously. I read it all, and it's very helpful in refining the course from semester to semester. It's also the case that I give you 140 characters to tell me your last remark, and I read that right before I assign your grade. So if there's anything that went wrong in the course for you, anything that you think got graded incorrectly, we do our very best to try to fix all those things before I assign grades, but you can let me know right beforehand. So that's one more reason to fill out the survey, is so you can give me your last remark, just helping me understand if there's anything that we haven't followed up on. Regarding grades, we're going to try to get everything up to date in GLOOKUP by next Monday, and then we're going to email all of you and say, here's what we think you got on all of your assignments. Please read that email and tell us if you see anything fishy, like a missing score for a project or something like that. We really need to get it corrected next week so that we can correctly give you what you deserve in this course. So look out for that email. And the glookup system, which you log into with your course account, is the source of truth by which we actually grade people in this course. So take a look at that and make sure it's up to date next week. And to give you one more reason to fill out the survey, because I think it's really important, if 85% of people do it, everybody who fills it out gets an extra credit point. Okay. So yeah, homework 11 is kind of a gimme. No. Oh, you want a tally of how many people have filled it out? I'll periodically post on Piazza. That's the best I can do. That's pretty low tech for a computer science course, but that's what you get. Okay, homework 12 is due next Wednesday as well. All you have to do is vote for your favorite recursive art. Recursive art, what's that? There was an optional recursive art contest as part of the Scheme project, and several of your classmates created beautiful, beautiful works of art, all running in Scheme on their own Scheme interpreter that they built, which is quite a remarkable feat. And we have now posted all of those in the Recursion exhibition. Thanks, everyone who participated. Let's take a look at what they came up with. These are in no particular order. Cute dog. These are in no particular order. We just randomly shuffled them. Everybody decided to enter the featherweight division, which is the shorter program, so we just put everyone together, except for one. The Eyes of John De Niro. Okay. Untitled. Right angles are many, but fewer and fewer, while recursion stays plenty. Complex sine fractal. 2 CS partners, blue and gold, traverse the bridge over the abyss. Turtles all the way down. What lies under earth? A great turtle rests below on turtles down, down. It's beautiful. Sally could have sold more seashells if she had not sold by the seashore. Gather ye rosebuds while ye may. Old time is still a-flyin'. Carpe diem. It's awesome. Where my grades for this class went. Flowers of Turkey. Simple, elegant, and pure. I just drew circles. My beauty, this is beautiful. I agree, this is beautiful. That's awesome. Untitled, Levy's recursion renders Cal at Cal deeper than our John's humor. Hey now. Moving on. Carried like a god, the weight of all this power, my shell feels heavy. Look at that cute eye. Save the turtles. Okay? This required only 25 tokens. Perhaps the shortest submission ever. Oh, a day under the Mandelbrot tree. And our first ever animated entry. It is called This Is the Best One. Oh, come on, Internet. 5 seconds, Internet. 4, 3, 2, 1.5. 1.25. Doesn't look good, folks. I'm going to refresh one more time. We'll see what happens. Show us content. There it is. And it's over. So let's give a huge round of applause to everyone. Really fantastic stuff. Thanks, everyone, for participating. So we'll post a link at the top so that you can vote on which one you like the best. But, I mean, clearly everyone's a winner. But then we need an actual winner. So that's where the voting comes in. Okay, so homework 11 gets you up to 22 points. Homework 12 gets you up to 24 points. You can have the last point for free. Okay, from here on out, you can focus on the final exam. Next week, we'll have 18 hours of review sessions on Monday, Tuesday, and Wednesday, running from 11 to 5. They'll run in 2 rooms simultaneously. One room will just cover practice problems. On the board, you can ask questions, of course. But there will be a fixed set of problems that we'll go over, and those will have specific topics that we'll post over the weekend. And our plan is basically just to walk through all the content of the course and show you some example problems on each topic. So if you want to go pick a topic that you're not feeling too comfortable about and see some example problems solved, you can go to review sessions. And then we'll have a second room that's totally open. You can go with any question you want, and people will be there to answer it. So this means if you want to get a head start on the whole studying thing, you could take a practice final over the weekend, see what you're feeling comfortable with and what you're not, and then work from there. Information about the final exam will be posted on the website. In fact, some of it's up there already, and so we'll just have a page that you can read, and it'll be linked at the top of cs61a.org. And we'll make sure to have the schedule of everything you're supposed to know here by tomorrow morning. Okay, any questions about that? So there will be at least two TAs available every hour. The tutors are going to come help out too. One room will be review, one room will be topic-specific problems, and just come with any questions you want anytime you want. And then the final exam is a week from Tuesday in the basketball court. That's the only place I can fit you all. So come to the RSF. Questions? Okay. I certainly didn't teach this course on my own. That was thanks to the staff that you already thanked. I also didn't build this course on my own. Many of the components of the course, including the labs and the Gorilla sections and the CS Mentors program, were all created or spearheaded or thought up by one person. His name's Andrew Huang. He came here to tell you about the lab assistance program but you can also just thank him. If there was anything in the course that you liked, it's probably due to him. Anything you didn't like, probably due to me. So let's give Andrew a warm welcome. Which mic do you want?
Hi. Everyone hear me okay? So, hi, I'm Andrew. I work in 61A, all of the stuff in the background, trying to make sure that you have lab assistants in your lab, trying to make sure that you guys have one-on-one tutoring, group tutoring, so on and so forth. This class is a lot of work, right, to take. Who here felt like there was some point in lab in the second floor dungeon of Soda where you were like, why am I taking this class again? This was a terrible mistake. I regret everything, right? And then, but arguably there was a moment like maybe hopefully immediately before, immediately after where you got a helping hand from either a TA or maybe a lab assistant, someone who just took the class a semester before you, and reminded you, yeah, everyone goes through this at least once. Here's what I can do to help. Here's how I approached it when I was taking it your semester, so on and so forth, right? There are a lot of people. I know this is a big class. I know it's overwhelming at times, and I know that a lot of times you feel alone and a little bit lost, but there's a lot of people around who's willing to help. You've seen this either in the labs or in office hours or maybe in group tutoring or maybe in one-on-one tutoring. A lot of people are out there to kind of volunteer their time and help out. Well, how did this come to be? It turns out when you teach a class of 1,000, you need an army to support it. So every year at the end of the semester, I come in and I try to recruit. I'm the army recruiter. Basically, we have this program now where we have students who've taken the class previously come back, and for one or maybe 2 semesters or maybe for the rest of their career at Cal, depending on how involved you want to be, they volunteer and they help and become the lab assistants you guys see everywhere, right? And they're responsible for answering questions. They're responsible for trying to help students one-on-one, maybe when a TA is busy, when John's busy, he's always busy. They try to answer some of the conceptual problems because they've seen it before, right? They see the moment where you get stuck, and they try to get you over that hump because that was them a semester ago, or maybe 2 semesters ago. And so I encourage you to come in, and we'll post the information on Piazza close to the end of the semester. Summer is already starting to recruit, where you can sign up if you're interested in helping out, if you're interested in becoming an academic intern, as the official term is, but we just call them lab assistants. Now, when I make this pitch, there's usually 3 things that go through your mind. 1 of 3 things, or maybe 2 of 3 things, or maybe all 3 things. Actually, mostly 2 of 3 things. The first thing, and I want to talk them through point by point. The first thing is that many of you listening to me right now immediately had this thought where you think, I'm not good enough to lab assist. Right? I barely passed this course, or I'm having a hard time right now, or Scheme.py was the most miserable experience in my Cal time here. Please, no more. Right? And you're like, if I can barely get through this class without even, I had to get a lot of help just to get through this class, how can I possibly help someone else? I would argue, or I would state in reply, that even if you feel like you're not yet ready or you're not prepared, even if you feel like you're not good enough, I disagree. You're wrong. You're good enough. We want your help, right? This class only runs so well because we have a depth of understanding. And what that means is not only do we understand how to explain the problem to you, we also understand what it's like to struggle. When I took the course, I did kind of terribly. I really had a hard time keeping up. I felt really bad about it my freshman semester. And I figured the reason why I lab assisted and why I'm still helping out now is I really didn't want anyone to have to go through that at all. But if they did have to go through it, I would hopefully was able to provide some level of guidance, right? Being like, you can get through this. If a screw-up like me can get through 61A, you guys definitely can, right? And that's why I volunteered lab assistant and eventually TA'd, and now I'm running things along the lines to try to help things out. And I encourage you guys to do it too. If you pass this course and you're willing to learn, those are the only 2 requirements for being a lab assistant, right? If you pass this course, one way or another, I don't care what grade you got, and you are interested in learning more. Not even that you're interested in helping, but that you're interested in learning and being passionate about how to best help the students and stuff like that, and you want to learn how to do that, then Lab Assisting is for you. We've had many students in the past who Lab Assist to go on and do some tutoring afterwards, and after that they become TAs. And we candidly ignore how you did your first semester in 61A if you prove subsequently that you were a badass, right? It takes sometimes a little bit of time and effort in order to get this stuff, right? Computer science is this big thing, and if you've never programmed before, it's going to take a little bit of time in order to get it under your fingers. And so, we discount one semester where you didn't do so well in 61A or whatever if you, did really well as a lab assistant, if you did really well as a reader, and so on and so forth, right? So that was reason number one. If you don't think you're cut out for it, I disagree. Number two, you might think that you're busy, or you might think that you don't have enough time. 61A took up my entire life this semester. I have to go catch up on Game of Thrones and compile a list of all the people who died. Well, it's not like this volunteer work goes unrewarded. There is a system where you get units to Lab Assist. So everyone who comes in and volunteers 3 hours a week over a fall or spring semester gets 1 unit for the entire semester. This is really nice because if you're like an LNS student and you need to make 13 units, you take your 3, really hard classes and they're 4 units each, and then you have that 1 unit that you don't want to go and take like some random decal just to fill the unit cap. You instead can Lab Assist, enjoy it, and then get rewarded, at least on Tellbears-wise, so that you are relatively okay, right? So that's the second thing. It's a quick, short spiel. You get units for Lab Assisting. It's really, the details will be posted on Piazza. 3 hours equals 1 unit. So if you do 6 hours, you get 2 units. I know some people, when I was taking my sophomore year, I actually did 4 units worth of Lab Assisting. So I was Lab Assisting 12 units a week. I dropped 1 too many courses. 12 hours a week, yeah, for 4 units. Okay. I don't recommend that, by the way. Lastly, and this is the most contentious point, some of you thought, well, I did this class. It was very enjoyable. I liked all of it. But I didn't really get help. It's not like I needed the help. I had some programming experience going in, or this all made sense to me going in, and I relatively, didn't really ask for help from the staff. I don't think it's a bad thing to get lab assistance, but I don't think it's for me. I don't think it's my problem, right? Some variation of that might have gone through your head. Well then, you have friends, I hope. And they may or may not be brilliant as you. But sometimes when your friends are having trouble, you'll help them, or maybe someone else will help them. But you have a lot of friends, hopefully. And don't you wish that they got the same level of support that you could give to all the people that you help out, like on one-on-one, or maybe that you see the TAs helping out in 61A? Don't you wish that everyone or everyone you care about does not have to face this whole, I don't know how to get this, I'm stuck, I'm going to hit my head against the wall for an hour and then I'm going to give up sort of experience, right? You could go and cure cancer, or you could be the best thing since sliced bread. That's great and dandy. But your friends will still maybe be struggling with the courses that you may or may not find easy, right? And if you don't help them out, who else is going to do it? Do you think everyone else in this room is going to step up? If everyone in this room has the same mentality, then we're hosed. Fall of 2015, with its 1,300 to 1,500 students next semester, will have a harder time than you guys did. Over the summer, Albert and Robert are teaching. This is really cool. I'm really excited for this. They're going to be recruiting for lab assistants, too. Are you guys going to post soon? I don't know. Is Albert still here? Yeah, so they're looking for help, and you guys have currently 340 students enrolled over the summer. That's more than any semester of 61A ever, right? This course is growing. This only works out. The growth only is justified because we have such a giant community who's willing to come back and say, I'm here to volunteer. I'm here to help out because I know how hard this is, and I want to make it a little bit less miserable for everyone after me. So if you're interested, if you want to volunteer, if you want to offer yourself as tribute, anyone who's interested in learning more about 61A, about teaching, and anyone who passes this class, if you have both those requirements, you're welcome. All right, come walk with me. Thanks, guys.
All right. So here's the part of the last lecture where I tell you what you learned in this course. That's in the rules when they make you a professor. You have to do this on the last day. So one thing you hopefully learned was what abstraction is, what that word means, and how it applies to computer science. That's fundamental, that you should be able to hide the details of something and still talk about it as a whole. And then the other thing that we talked about in this course is called programming paradigms. And programming paradigms are different approaches to building a large program in a way that manages the complexity of that program. And we really learned three. We learned about functional programming, where you define your large program in terms of lots of little functions, and in that way you can test each part, and you can build new things by composing together those functions in various ways. And at the very end of the course, we saw there are some advantages to that, because if you write a bunch of pure functions, then they're easy to parallelize on lots of machines. We learned about object-oriented programming, where if you have things that change in your program over time, state, instead of just having one global frame where all that state goes that tells you where all the ants are or whatever, instead, you put all of the state in... Oh, okay. That's me.
Awesome. Here's your birthday present.
Oh, wow.
From some anonymous student in your class. You have to sign here, though. Sorry to interrupt.
I will never sleep again.
Thank you so much, sir. Happy birthday.
Thank you very much.
Turning 26 today, right? 27?
Yep, 26. That's right.
Thank you, guys.
Okay. Well, back to programming paradigms. So object-oriented programming is supposed to be good at taking the state of your program and breaking it up into lots of little objects that interact with each other through message passing. And then we talked about declarative programming. We learned SQL, which was a language where you say what you want, but not how to compute it. And it's somebody else's problem of how to compute it. And that's kind of why SQL is this extremely popular programming language that everyone uses, is that you don't necessarily have to think about the procedure that's going to compute the result you want. The people who build the database systems do that. So, now what do we do at the end? Well, we should decide which one is best. No, I'm kidding. What you do at the end is appreciate how these different paradigms solve different problems and how we can use them all together. And so if somebody ever says to you, oh, functional programming is better than object-oriented programming or something silly like that, just say, every programmer needs to understand these different ways of approaching software engineering. And they all have their different uses and their different benefits. Okay. So that's hopefully what you learned in this course. Yeah, well, we almost have time for this demo. I'm not going to type in the code, but I just wanted to show you one demo that tells you something about what I do. So I spent all of last lecture telling you about this problem called natural language parsing. Some of you were at last lecture. Maybe the others watched the video. If you weren't there, the gist was that you'd take in a sentence like, programs must be written for people to read, and try to figure out its structure. So its structure is that it's a sentence with a subject and a verb. This predicate, the verb phrase, has a subordinate clause within it. And this structure is a tree structure that tells you what clauses fit into other clauses, etc., until you get a whole sentence. And we spent the whole lecture building this thing up, but we didn't really do anything with it. So I figured I'd show you the kinds of applications that this sort of analysis is used for. What can you do when you know the structure of an English sentence? Well, you can translate it. And typically the way translation happens, for instance, from English to Japanese, which has a very different word order, is that you take the English sentence and you shuffle its words around until you get an order that looks more like Japanese. Now, I'm not sure everyone in the audience speaks Japanese, so I'll do a different example. I'll do English into Yoda, where Yoda says things like, "Help you I can." Yes, And when 900 years old you reach, look as good you will not. Okay, so how do you make Yoda? Well, Yoda takes in an English sentence, comes up with a parse tree for it, and then what he does is he takes the clause that is following a modal verb like can and moves it to the front. So the help finds the can, takes the help you, moves it to the front, and we'll stick in a comma. Now, this is something you can only do if you know where the modal verb is and what clause comes next. Then you can turn "I can help you" into "help you I can." Seems simple enough? So, why don't I just show you how it works? So all we're going to do is take in a line of text, parse it, print out the tree, just so we know that our parser works correctly. So this would do something like, if I say, "I can help you," it'll say, "Oh, I can help you" is I, and then "can help you," and a person like me would say, "I can help you." But changing it to Yoda speak is only this long. You go and you find a modal verb, and you take that clause, and you put it at the beginning. I'm sorry I don't have to go through the details, but I'll just show you what it does, okay, because I really like this. I couldn't let the class go by without showing you what happens when you say, "I can help you." And it automatically takes that sentence, finds the structure, says, "I can help you," moves the modal verb to the front, and Yoda says, "Help you, I can." Or it says, "Students should study for the final exam." Yoda says, "Study for the final exam, students should." And it even knows what part to move. "Study for the final exam" wasn't the rest of the sentence. So if I had a really long sentence, like, "Students should study for the final exam, and I should write it." It has to figure out the structure of that whole sentence, which is something complicated, and then Yoda says, "Study for the exam, students should, and I should write it." Yoda, you're not the one writing it, I am. So, if you see questions on the final that are in Yoda speak, you'll know why. Okay, that's my last demo. We've come to the end. I like to spend all of 2 minutes talking about life. Because actually there's slightly more to life than 61A. Well, you could just take 61A over and over again. That would make me happy. I teach it over and over again, and it's awesome. But out there in the world, you probably took 61A for a reason, because you thought it would be useful to learn this stuff. And it turns out that it's really useful. There are more people in the world who want to collaborate and work with someone who understands computer science than there are people who understand computer science. So your skills will certainly be in high demand. So let me just give you some opinions. These are not facts. You can choose to ignore them. But I think they're useful things to keep in mind as you go forward in the world with this newfound knowledge. 1, being in demand gives you freedom. Yeah, it might give you a higher salary, but really what it does is it gives you the choice of what to work on. There are all these people who want you to work for them, or work with them, or they want you to work for you, or whatever it is. But the point is, you're going to have to choose. There are too many problems in the world to solve, that involve computing than all of you can solve even together. So be opinionated about what you work on, because you are going to have the flexibility to decide. And it matters what you choose. That will influence what gets done in the world. The second thing I'd keep in mind is about power. So it turns out that technology is concentrating power. The people who understand how to extend and apply computing technology are getting power in the forms of lots of wealth, but also political influence, and people listen to their ideas more. And you're the ones who understand computing now. So that means people in this room are going to be the ones who decide how the world works in the future, basically. And so you should keep in mind that as you accumulate power in the world, you're the one that has it, and so you shouldn't screw up the world. That you should pay attention to the choices you make and the consequences that they have on other people. So what does that mean? I'll tell you what it means for me. I feel like the wonders that we have today, because life is pretty great. We live a long time. We have a lot of things. That comes not just from a few individuals, but from an accumulation of the contributions of many, many people before us. That's called progress. That's a good thing. And I'd like to see that keep happening. So to me, that means lots and lots of people need to keep contributing new ideas to the world in order for us to continue that progress. So if we're not careful and only a few people get to contribute, well, then that will be unfortunate, and that would slow down the pace of change in the world. So I spend my time on education because I think maybe I'll have some effect of getting more people able to contribute. And you can decide what this means for you, but certainly try to work toward a world where lots of people have a say in the world that we're building. Third thing. So we did freedom, we did power. We're going to do self-worth. What's your self-worth? It's a weird thing. It's an important thing, actually. When I got married, my mom pulled me aside, and it was on my wedding day, like an hour before I got married. She said, "John, I want to talk to you." And I thought she was going to say, pay attention to your wife or something like that. She said, "I have advice for you. Don't compare. Your self-worth is due to what you achieve, what you're capable of, what you know, what you decide to spend your time on, and has nothing to do with what everybody else in the world has achieved. And so, just focus on what you have to offer, how you're going to spend your time, what contributions to the world you'll make. And when it comes to getting married," she pointed out, "you shouldn't worry about what other couples are doing. Just focus on yourselves. And you'll lead a more fulfilling life." This was very hard advice for me to take, because I had spent a lot of time in school. That's what happens when you become a professor. You spend a lot of time in school. And school always has you compared to somebody else. Like, what score did you get on this test, and what grade are you in, and are you in this fast math course or the slow math course? It's all about comparing. But that comparison actually doesn't matter so much as what you can do and what you've learned. And so it's been very hard advice for me to accept, but some of the most useful advice I ever got. So I thought I would share it with you. So just wanted to tell you those three things. Go out, take some more computer science courses, change the world, appreciate your freedom, make sure that you use your power wisely, don't compare yourselves to others, and thanks for being a wonderful class. It really has been an extremely delightful semester, and that's all I got. Last 10 minutes, they're going to distribute surveys. Please stay and fill out the survey. I would really appreciate it. Have a good summer.
Hello, everyone. We're from HKN. You're going to be getting 2 forms, a blue one for the instructor and an orange one for your TA. After you're done, please turn them in. We'll have envelopes in the front. And please do it in pencil. Oh, and answer this question in the free response section of the instructor form. So in the blue form, you'll have a space for free response. Please answer this question. Please raise your hand if you do not have a green or blue form and an orange form. Okay. Go. So if you still need a blue form or an orange form, please raise your hand. And if you have extras, raise your hand, we won't get them. And the envelopes in the front are alphabetical order. So on the left, they're ordered by the first name of your TA. starting from A on the left and Z on the right.